Hello, Niall here from Comscope. I'm going to discuss our DCIM solution, iTRACS. We're looking at the issues today in the data center, trying to manage connectivity, copper, fiber, power, connectivity, managing resources and growth, coping with rising energy costs, increasing energy usage, building in redundancy and resilience in order to maintain this 99.999% uptime. A recent DC survey on trends and challenges shows these issues are all coming up in the top 10 when it comes to day-to-day challenges in the data center. Well, addressing a lot of these challenges and more is iTRACS. It's a world leader in DCIM. It's recognized in the industry as a proven solution, and it's deployed in some of the world's most complex infrastructures. Some of the business benefits of iTRACS: more transactions per watt of energy, so you can match the best performing servers to your applications. Improved revenue per rack, so you can eliminate stranded power and maximize capacity utilization. Manage workload capacity for rapid disaster recovery to get revenue generating capacity back within minutes. There's predictive modeling, so you can maximize the efficiency of the existing footprint. You can defer or eliminate the need for millions in capital expansion and achieve optimum efficiencies in space, power and connectivity. For audits and asset management, it's a real benefit to have one single repository for the entire IT ecosystem. Of course, you can reduce energy costs and free up rack space. You can identify, decommission and consolidate zombie servers. You can manage business growth based on forecasts. Use automated reservations to hold these resources for planned changes. There's a future view, so you can predict future capacity in terms of power and space and cooling. And you can use what-if scenarios to test expansion strategies before going live. You can track growth as it responds to anticipated demand, so you can understand interdependencies between physical servers, virtual machines, switches, and other IT assets as your IT ecosystem evolves. Point-to-point connectivity with granularity right down to the port, so you can uncover and resolve network problems without putting other network resources or business transactions at risk. You can manage connectivity right down to the physical port, whether that's fiber or copper or power. You can just click on a server in the server row and see all the connectivity from that device, tracing all the way back to the source. A big strength of iTRACS is the built-in analytics. So here's a PDU in our data center. It's providing power for some of our assets. But what if it trips or fails for some reason? Well, with the click of a mouse, we can see the potential impact in this what-if scenario. The SAN devices in yellow on the left, they have redundancy which they're going to lose, but they won't fail, they won't go down. The servers in blue won't go down, but they're connected to assets in the SAN area which may be affected, so you can see straight away there's an interdependence there. The equipment in red will fail. Some of these have no redundancy and they're going to go down if the PDU goes down. We can also look at a future view, which is a unique feature to iTRACS. In this case, we have a server row here with a number of underperforming servers that have been identified. Software gives us a list of these and also a suggested alternative. The alternative provides the same level of service, but requires less resources, less power, less rack space, and less connectivity. We can generate the planned changes to commission the new one and decommission the others. And the future view allows us to see all of this before it actually happens. So here's day 2. Our replacement server has been installed and commissioned in the rack. Then as we look ahead, by the end of the month the new server is in place, all of the work has been completed, and the idle servers have been taken out, freeing up rack space, connectivity, and power which can be reassigned and reutilized. Well, iTRACS is a very open system. It's quite straightforward to incorporate data that's been sourced from other technologies, other systems. And once imported, this data can be utilized by the analytics technology within iTRACS. So for example, with Intel Data Center Manager, we can gather real-time server data, sensor temperature, power consumption, and so on. And this data can help us make informed planning decisions on utilizing resources within the data center. At the front end, the application can be accessed with a Windows client, a full 3D visualization experience. and also through the browser or the iPad app. When it comes to sustainability and the environment and addressing the green issue, iTRACS can easily be utilised to make a substantial impact here. According to a recent study, the ICT ecosystem is now approaching about 10% of world electricity generation. Per year, that's roughly the total of Japan and Germany combined. Put another way, about the same was used for global illumination in 1985. Now, the New York Times did an investigation in the US and found that 90% or more of the electricity being consumed in data centers is actually just wasted. For example, more than half of the service that they looked at turned out to be zombie servers, or comatose devices. They were consuming power, connectivity and space, but they weren't actually doing anything. And even looking at the equipment that was utilised, there was on average less than 10% CPU utilization. So essentially data centers are largely over-dimensioned in this pursuit or drive to maintain this 9 times uptime, 99.999% uptime. Additional resources are often added, but there's already ample existing resources in place. But of course, if you don't know exactly what you have and how it's used, then it's often less risky just to add additional resources just in case. There are incentives to knowing what you have and how it's utilized. Take out just one idle server, for example, and save $500 per year in energy costs, another $500 in license fees, an additional $1,500 in terms of annual maintenance costs. And that's not including the cost of one new rack space, which will free up as well. On a larger scale, the numbers add up. America Online took out about a quarter of their servers in 2012. They saved over $1.5 million in energy bills, lowered the carbon footprint by 20 tons, and they gained a further $1.2 million through scrap and resale. Of course, it's not always that straightforward. What if some of those were actually running applications or were used occasionally for something important? But with iTRACS, you can easily isolate underperforming assets, and then you can quickly see the impact, if any, of taking these out. All of this can be done offline and verified first in a what-if scenario without having to take any risk at all. And here's how.
So here's the challenge you face. Your best guess is that between 15 to 20% of your servers are underutilized or unused, consuming electricity without adding value to the business. Maybe the applications have been migrated to virtual servers, or M&A activities have shifted operations. For whatever the reason, servers that were once useful are now dead weight. They need to be removed to save power and free up rack space. The problem? You don't know where they are. Fortunately, iTRACS CPIM lets you search for any servers based on any criteria you put into the system: end of lease, business unit, model, CPU utilization, or any other drill down you'd like. Adding CPU utilization to the real-time power readings from Intel, we search to confirm which servers have consistently low CPU and memory activity. We find a host of servers in which no business applications are running. The boxes are essentially unused. We drill down into the power usage of each server and to confirm the CPUs are vastly underutilized. But the question remains, why? We run a line of business search and it confirms that the business unit was dissolved months ago and the applications were migrated elsewhere, but no one turned off the servers, so now it's time to shut them down. We run a connectivity trace across the infrastructure to make sure there are no potential problems downstream, and it looks like there will be no problems. So we walk through a step-by-step sequence for decommissioning. A summary report is submitted to the change board identifying power cost savings and requesting permission to decommission. Approval is granted. The servers are removed and placed in inventory for other business units to repurpose. And the bottom line is a big one. We have 15% more rack space available to expand capacity. We've reduced our energy consumption and costs, and we're obtaining the same business output at a lower overall power usage.
Concludes this presentation. Thank you.